Hey guys, so here's our last video for 4.1. The instruction states, find the extreme values of the function and where they occurred. So even though the wording is slightly different from the first few examples, but how we find extreme values, we have to do it the same way by first finding the critical points. If there are any endpoints at all, we use the endpoint and the critical points and plug it back in. If there are no endpoints, in this case, in this example, we do not have any endpoints, then all we need are the critical points, okay? So critical point meaning that we need to take the derivative and we set it equals to 0, or where the derivative does not exist. So first, we are going to take the derivative. I'm going to rewrite this as a negative power, because it's a little bit easier to do the derivative using a power rule. So negative 1 times x squared minus 1 to the negative 2 power. And the chain rule states that we need to take the derivative of the inner. So that gives us y prime equals negative 1 on the top. The denominator is now x squared minus 1 to the power of 2. The derivative of x squared minus 1 is now going to be 2x. So we are going to have negative 2x on the numerator, x squared plus 1 quantity, not plus 1, minus 1, quantity square. So we want to take this and we want to set it equals to 0. When you take it and set it equals to 0, the denominator will disappear anyway, because when you cross multiply, anything times 0 is going to give us 0. So all you have left is now going to be the numerator, which is negative 2x, and take it and set it equals to 0. Negative 2x equals to 0. That means you have x equals to 0. That is your critical point. Now, we also have to take into account of where the derivative doesn't exist. Now, if you look at the denominator, x squared minus 1 quantity square, the denominator can never ever be 0. So what if we take that value, or take the denominator, and we set it equals to 0? And it's a whole quantity square, so we don't have to do it twice. So this is x squared equals 1. That means x equals to plus or minus 1. These two are where the derivative does not exist. And the reason the derivative doesn't exist, we have to go back to the original to see what the relationship is. The original is a rational function, meaning that you're going to have asymptotes. So the derivative doesn't exist because these are vertical asymptotes, which means there are discontinuity. So we have those two values, vertical asymptotes at x equal to plus or minus 1. Now, we can't plug in the vertical asymptote because it doesn't exist in the function anyway, so we don't need to worry about those, okay? So currently we only have one critical point. So f of 0, when we plug in f of 0, it's going to be 1 over negative 1, which is going to give us negative 1. Well, when you draw your number line with one point, it is very difficult to see whether that's a max or min. So what you want to do is find the end behavior, f of a negative 100. Remember, I'm using negative 100 all the time just because for me it's easier. You don't have to, you can use negative 1000. You can think of it as limits as x approaches negative infinity of f of x. That's exactly the same thing. And then we also use, for me, I'm using positive 100. Again, that's the same thing as thinking, okay, well, the end behavior, right side, that's going to be positive infinity of your regular function. Either way, it should give you the same picture. So I only have one critical point at x equals to 0. We got a y value of negative 1, so I'm plotting a dot below. It's really, right now, I can't tell at all if it's max or min. You do have two asymptotes. I will now plug those asymptotes in. How about we go negative 1 here and positive 1 here. So these are the asymptotes. Well, if we have two asymptotes, you know from before in algebra 2, there should be 3 curves for this rational function. Well, on this left side, we don't have any critical point. On this right side, we do not have critical points either. Therefore, there will not be any minimax on either. There will be one in the middle, maybe, depending on what's happening, okay? So let's go and pick two more values in the middle, near the asymptote. So let's see if we decide a -½ and f of a +½ The reason we're picking two more points is because we cannot decide whether the point at 0, -1 is a relative max or min, or an absolute max or min. So we have to pick somewhere another 2 points just to see. All right, let's plug it in. Let's start with the -100. If we plug in a -100, then as you can see, the end behavior function, it's going to be 1 over -100 squared minus 1. So we're going to have, let me just erase these two green dots here. It's going to be 1 over -100 squared, and we have minus 1. This is going to be a positive answer, but it's very small, positive close to 0, okay? Then when we do 100, because it's x squared, so it's always going to be very similar, this is always going to be, again, positive close to 0. That's what's happening to the end behavior. Now when we plug in a -½ that's going to give us 1 over -½ quantity squared minus 1. That will give us a -4 over 3. When we plug in a positive half, it will also give us a -4 over 3 because it's the x squared. So because it's -4 over 3rd, that's slightly, as you can see, lower than a -1. So if I were to plot those two dots, they're about here. So in sketching this out, it should look like this. Left end behavior, it's close to 0, and it's positive. That means it's above the x-axis, okay? Same thing with right end behavior. As x approaches negative and positive infinity, it is getting closer and closer and closer to 0. Then in the middle, because we have those three dots, it's going to look something like this. So as you can see, we have one relative max. So local, which is the same thing as relative, max is -1 at x equals to 0. One last question and we're done with 4.1. Okay, so similarly to this one, it's a rational function. So we want to find the critical point by taking the derivative. And let's write this as a power function. 1 minus x squared to the power of -1 over 3. Okay, y prime equals -1 over 3 times 1 minus x squared to the -4 over 3 times -2x. Let's make it pretty. Let's see, we have a -2x already. So on the top will now be a positive 2x. On the bottom is a 3, and it's the third index of 1 minus x squared, all of it to the 4th power. So I just have to be very careful. All right, similarly, we're going to set it equals to 0 to solve for x. The denominator will disappear, so all you have left is 2x equals 0. That means the first critical point is when x equals to 0. Now let's check out the denominator to see where the derivative does not exist. So that means we want to take the denominator and we set it equals to 0. So 3 third root 1 minus x squared, all of it to the 4th equals to 0. You can ignore the 3. If you cube both sides, 0 cubed is still going to be 0. So 1 minus x squared to the 4th power equals still 0. Take the 4th root, it's still going to be 0. So 1 minus x squared equals 0. We are going to move the x squared to the right, so 1 equals x squared. So that means x is going to be plus and minus 1. This is where the derivative doesn't exist, but let's see why that is. Let's connect that to the original function. Well, the derivative does not exist at x equals to plus or minus 1 because the original function is discontinuous at those places, okay? Those are VA. So we have two VAs at x equals 2 plus and minus 1. When we are plugging in points, we don't necessarily have to plug these in because the original function doesn't exist anyway. Okay, so let's go and find f. We have one critical point at 0. F of negative 100, a left-hand behavior. We can think of it as limit as x approaches negative infinity of f of x. And then we do f of positive 100. Think of it as limits as x approaches positive infinity of f of x. So the first one's negative infinity, and then this one positive infinity. Let's plug it in to see if that's enough information for us to decide whether our one critical point is min or max. So when you plug in 0, everything's going to disappear besides 1 over 1. So f of 0 is going to be 1. Now let's plug in negative 100. When you're doing end behavior, you only need to worry about the powerful term. So on the top, you only have one choice, which is 1. But on the bottom, you have third root of 1 minus x squared. So the more dominant term would be negative x squared. So it would be a third root of a negative x squared. This is all we have to worry about. So 1 over third root, negative quantity, this is negative 100 squared. Well, 1 divided by something really, really big in the bottom, okay, it's going to be a negative number, but close to 0. So negative close to 0. Same thing with this one. You only need to worry about the powerful term. Let me have 1 on the top, third, and then let's plug in 100 squared. That's a positive number. Very, sorry, I forgot the negative sign. It's a negative x squared, so it's negative always in the front, and then plug in 100 squared. So again, same thing, it's a negative number, close to 0. So what does this look like? Well, if we were to draw a number line, oops, there you go. Here's 0. At 0, we have a positive value of 1. We have two asymptotes. They are at negative 1 and positive 1. It is not enough for us to determine whether it's going to give us a max or min. Now on the right side and left side, we can see that it's negative. So that means if we were to sketch this out, it kind of looks like this, okay? As x gets towards positive or negative infinity, it's below the y-axis because it's negative and it approaches 0. Now in the middle, we know there's one critical point, but it's not enough for us to find if it's max or min. So again, I'm going to go and pick f of a negative half. You don't have to use negative half. You can use a negative quarter and a positive half. My whole goal is it going to be higher than 1 or lower than 1? And if I know that, then I would definitely know if it's min or max. So it's 1 over cube root. It's going to be 1 minus negative 1/2 quantity square, which is 1 over cube root of 1 minus positive 1/4, which is 1 over cube root of 3/4, okay? Well, I don't need to know the exact value, but as you can see, the bottom is a fraction, and 1 divided by a fraction that's going to be less than 1 my answer is going to be bigger than 1. That's all I need to worry about. I don't care the exact answer. And because it's x squared, when I plug in negative 1/2, the bottom's now positive 1/2. Sorry, fix that for me. When you plug in a positive 1/2, you should get the same exact answer because it's x squared. So this one, it should come out to be the same thing. And they both are above 1. So if I know it's above 1, and we don't care how above, it just has to be higher, then we know it opens upward like that, right? So if it opens upward, we immediately know that it's a local minimum. So L min is 1 at x equals to 0. And that concludes our 4.1.